This is the second video for section 2, and it is the first of two videos on a topic called significant figures. In this video we'll define and show how to count significant figures, and in the next video we'll show how to do math with significant figures. So for significant figures, it turns out that when you're looking at a number, not all numerals in a number matter. The numerals that do matter are called, cleverly enough, significant figures. Now it turns out there are two types of numbers. Measurements, which as we learned in the previous video are inexact, and there are defined numbers, and these are exact. Measurement, something that you measure. I know that is using the word to define itself, but you know what I mean. For example, you take a look at the screw, put it against the centimeter ruler, you see that this is where the tip is, and you always read to 1 decimal point beyond the markings. So I would say this is 5.11 centimeter, but somebody else may look at it and say, well, actually I think it's 5.10 centimeters. That last digit is somewhat whiffy. A defined number, on the other hand, is not whiffy. Example, here we have 1, 2, 3, 4, 5. We have 5 penguins. Nobody's going to look at that and say, well, really, I think there's 4.99 penguins, or I think there's 5.02 penguins. It's a count. You know exactly how many there are. So it turns out for a defined number, there are three types of number. A count, 45 cars in the parking lot. A mathematical number, use the number 231. And conversion factors. 60 minutes is defined as 1 hour, so that is considered to be a defined number. Just so you know, significant figures is frequently written as sig figs. So how many sig figs are in any given number? Well, it depends upon whether you have a measurement or a defined number. And we'll tackle the measurement first, and for a measurement, you have to calculate the number of significant figures. It's going to vary. The method we're going to use is called the box and dot method, and this is a typical stepful chemical process. So we have to start with some definitions. A non-zero digit is a digit from 1 to 9. 0 is 0. A leading 0 is a 0 to the left of the first non-zero digit. So for this number, these 3 zeros are significant because they are to the left of the 3, which is the first non-zero digit. Trailing 0, a 0 to the right of the last non-zero digit. So for this number, the 0 between the 6 and the 5 is not a trailing 0, but the 2 zeros after the 5, which is the last non-zero digit, are trailing zeros. With those definitions, we can go to the steps, and we'll use a measurement, and I'll show you how to do it step by step by step. So you start with a measurement. This has a unit called milligrams. The first thing you do is put a box around each individual non-zero digit. So a box goes around the 1, the 3, the 2, and the 1. If a 0 is anywhere between boxes, then you put a box around the 0. So this 0 is between 1 and the 3, it gets boxed. This 0 here, there's a box around the 3, a box around the 2, and this 0 is in between those two, it gets boxed. This 0 gets boxed. These last two zeros do not get boxed because they are not between two boxes. If there is a visible decimal point, you box all trailing zeros. There is no written decimal point here, so these two zeros do not get boxed. Never box a leading 0. And now you count the boxes, and when you do that, you see you have 1, 2, 3, 4, 5, 6, 7 boxes. This measurement has 7 significant figures. How about if you have a defined number? A defined number, by definition, has an infinite number of significant figures. So if we look at our previous defined numbers, 45 cars, infinite significant figures. 231, infinite significant figures. 60 minutes per 1 hour, once again, infinite significant figures. Why infinite significant figures? You'll have to wait for the next video to find out. So here's an example for you to try, and then we'll go through it. You have 2,035.20 kilometers. This measurement contains how many significant figures? Figure it out, come back, check the answer, and then we'll go through it. Go. The answer is 6 significant figures. We start with a number. We box each individual non-zero digit. We box the individual zeros found anywhere between two non-zero digits. So that's this one. If there is a visible decimal point, and there is one here, you're going to box the trailing zeros, never going to box a leading zero. So when you count the boxes, there are 6 significant figures. Second example, 0.0035020200 nanoseconds. Once again, a measurement. Have to know the significant figures. Figure it out, come back, check your answer, and then I will take you through it in a stepwise fashion. Go. And the answer is 8 significant figures. Start with the number. Box non-zero digits. Box the zeros that are between boxes. If there is a visible decimal point, and there is, box the trailing zeros. Never box a leading zero. Count the boxes. You get 8 significant figures. One more example, and then this video will be completed. You got 210,010 books. How many significant figures do you have? Stop, figure it out, come back, check it per the usual, and then we'll go over it. If you got 5 significant figures, you're wrong. The correct answer is infinite. This is a defined number because we counted the books. This is a count. Defined number, infinite significant figures. So to review, significant figures are used to tell how precise data are. For measurements, you need to calculate the number of significant figures, use the box and dot method, box all non-zero digits, box any zeros between boxes. If there is a visible decimal point, box all the trailing zeros. Never box leading zeros. Count the number of boxes, and if you have a defined number, things like counts, math numbers, conversion factors, you have an infinite number of significant figures. That's all you have to do to count or figure out significant figures. In the next video, we're going to show you how we do math with significant figures, which answers the ever popular question, how many decimal points in the answer?